Alright, this is notes for 171, section 17, part 2. We're going to do compositions of functions. So compositions of functions, we're going to put one function into another function. Okay, and the way that we say this is f of g of x. So g of x, if you kind of ignore the f, g of x, that's the notation we've seen before, and then that's in the place where we're typically used to seeing an x. So we say that f of g of x. Okay, now the way this works is the input goes into the g function first. We get an output, and then that output, the whole entire output, then goes into the f function. Okay, you can see it, I think, in my opinion, you can see it better here. X goes into g, and that output is g of x, and that goes into f. Alright, now, the domain of the composition. It's all the x's that go into g, and then g of x after that's a domain of f, after we've composed. So the thing that you got to understand here is the original domain of f, okay, which by that we mean the outer function. Is not considered. Okay, so when we were doing composition, we had to remember the original domain of f and the original domain of g. But the original domain, original domain of f here does not matter. Alright, so let's look at this. Let's understand what a composition looks like. So f triples an input, subtracts 4. G squares an input, subtracts 2, adds 6. And we're going to take all of G and put it into F. Right? This means G into F. This means F into G. Okay, that's what we're going to do for part B. Let's put G into F. So that means all of this, x squared minus 2x plus 6, is going to replace this x right here. So all of this is replacing that x. So I would write f of g is equal to 3 parentheses, there's where the x was. I'm going to replace it with x squared minus 2x plus 6, and then minus 4. Alright? Then you simplify. Distribute the 3 through, I get a 3x squared minus 3x squared minus 6x plus 18. Okay, 3 times all of these minus 4. And then it gives me a 3x squared minus 6x. 18 minus 4 is 14. Okay? The domain of this and this are all real numbers. This is also a polynomial, so its domain is still all real numbers. Alright, now put f into g. Now, 3x minus 4 is going to replace each of these x's. So every time I see an x in g, I'm going to replace it with all of this function. So I'm putting all of this function into this function. So g of f is, here's an x that's being squared. I'm going to replace that x with 3x minus 4. Okay, that gets squared. Then minus 2 times x, again I'm going to replace that with 3x minus 4 plus 6. Alright, now remember, don't just square this and square this. FOIL it out. 3x minus 4 times itself. That's what squaring means. You're multiplying something by itself. Here I'm going to distribute the minus 2 through. So minus 2 times 3 is minus 6x. Negative times a negative is a positive 8 plus 6. Alright, FOILing this out, I get 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is another negative 12x, so that's a minus 24x. Negative times a negative is a positive 16. And then the minus 6x, 8 and 6 is 14. And then combine your like terms. So we get 9x squared, nothing else is like that. Minus 24x minus 6x is minus 30x. Plus 6 plus 14 is plus 30. Right? Again, polynomial, so still no domain restrictions. But the thing I want you to see, the thing that we did this problem for, is they're not the same. This is g of f. This is f of g. Okay? They're not the same thing. So in general, f of g is not equal to g of f. Now it can be. There are situations where it does, and it's a special situation when they are equal. And we'll talk about that later. But just know that in general, you don't see these two things being the same thing. Alright, now, and if it doesn't have an x there, if it has a number, then that's saying plug 1 into f. Figure out what that is when you get 1 out of into f, whatever you get out. Then plug that output into g. So 1 goes into f, you get another number. Plug that second number into g. So if I plugged 1 into f, here's f. It triples the number, then subtracts 4. So 3 times 1 is 3, minus 4 equals negative 1. Now negative 1 is what I'm going to put into g. Alright, if I plug negative 1 into g, square negative 1, I subtract 2 times negative 1, and then I add 6. Alright, I'm just doing what g says to do, but 2 negative 1. Negative 1 squared is positive 1. Negative times a negative is a positive 2. Plus 6, so 1 plus 2 is 3. Plus 6 is 9. Okay, now, if I plug negative 1 into g, and then that into f, negative 1 goes into g first. Well, that I know that g of negative 1 from the very last problem, when negative 1 into g, we ended up with 9. And now I'm going to plug 9 into f. So here's f. I'm plugging a 9 in where that x is, so 3 times 9 minus 4. Alright, so 3 times 9 is 27. And then 27 minus 4 is 23. So g of negative 1, sorry, f of g of negative 1 is 23. G of f of 1 is equal to 9. Okay, so just note that's what we mean. We mean plug this into the first function you come to first, get a new number and output, and then plug that output into the second function, or the other function. Alright, now, coming up with the domain when we do this. So if x is not in the domain of g, it can't be in the domain of the composition. That's what this first line is saying. So we always include the restrictions for g. And then in addition to that, if we get a new restriction once we do the composition and simplify it, then we have to exclude that as well. So we're going to do f of g. Okay, that's the inner function. Again, that's what we mean up here. G is the inner function, the one that x hits first. Okay, so here's g. So x, because if x is 0, we divide by 0. X can't be equal to 0. So 0 is going to be restricted no matter what happens when we do the work we're getting ready to do. We have to exclude 0. Okay, now f composed of g. We're going to take the g function. Okay, we're going to take this 1 over x right here, and we're going to replace this x with it. Okay, that's what it means to plug in a function into another function. You replace the x variable here with this entire function. So f composed of g is equal to 4 over, instead of x plus 2, it's 1 over x plus 2. Okay, now we want to simplify that. So the easiest way to simplify is to multiply top and bottom by the LCD of the fractions in the top and bottom. So the only fraction is 1 over x, so LCD is just x. So I end up with a 4x in the top, and I have to distribute here. Just think about there being a parentheses here, and you're distributing this x through. So it's going to cancel out with this x here and leave you with just a 1. Here, you're going to end up with a 2x. Okay, now, 0 is fine again. 4 times 0 is 0, 1 plus 2 times 0 is 0, 1 plus 0 is 1. 0 over 1 is fine, it's defined. But once again, you can't lose this restriction from g. Okay, if it's not in the domain of g, it must not be in the domain of f of g. So we can't get rid of that 0 restriction. Alright, now we do get a new restriction. 1 plus 2x can't be equal to 0 either. So I set it equal to 0 and solve. Minus 1 both sides. 2x equals negative 1, so x equals negative a half. Okay, so that's another new restriction. X can't be this either. I can put a little not equal to sign for that equal. So the original restriction for g only is excluded. The restriction for f of g, once you compose them, if we have a new restriction, it's included. So the restriction here, the domain here, is going to be negative infinity all the way up to the smaller of the two restrictions, which is negative a half. And then union the smaller restriction to the bigger restriction, which is 0. Union 0 to infinity. Okay, so you have to include the original restriction of g. You have to include any new restrictions that come up from the composition and simplifying. But you don't, now notice, f negative 2 doesn't work here. Negative 2 plus 2 is 0. Negative 2 is not restricted. Okay, it's fine for negative 2 to go into the g function. It's fine for negative 2 to go into the composition. If I plug in negative 2 here, it's fine. Negative 2 doesn't work in f, but notice that does not get restricted. Okay, it's only the things that result from composing the two and the things that were originally restricted in g. Okay, the inner function. Alright, now the reason is because the inputs go into g, this happens to them, and then they go into f. If I take negative a half and plug it in here, 1 over x just means reciprocal. So the reciprocal of negative a half is negative 2. So negative 1/2 is what causes negative 2 to go into f, and that's why it's restricted. Okay, but we don't directly ever include the restrictions of f, or the outer function, into the restrictions of the composition. Alright, now this is working backwards. So we've got a function, and we want to come up with two functions that I can write. One went into the other and gave me h. Okay, so we want g to be the inside function, and we want f to be what we call the outside function. Okay, so this is very important for those of you who are going into calculus to be able to do this, be able to see who's inside and who's outside. So the easiest thing to do here is, like, if you see a radical, is just to kind of cover up everything under the radical, like pretend that it's not even there. So if you have a radical like this, just pretend that there's just an x underneath that radical. Alright, so I'm going to just put an x there. Right, and there's your outer function. So we could say the outer function f is the cube root of x. Okay, so I'm just kind of ignoring what really is under there and just thinking of all that as just x. And then your inner function is what really is under there. So g of x is equal to the stuff that really was under the radical, x squared plus 1. Okay? Now the reason why that works is because it says put g inside of f. So if I put this where that x is, I get the cube root of x squared plus 1. So it works. Now, the other thing is, for you to understand, is that that's not the only 2. It just says find 2. It doesn't say find the 2. Like there's only one pair that'll work. So for instance, if I did f of x was equal to the cube root of x plus 1, and then I said g of x equals x squared, it still works. Okay, if I replace this x with x squared, I get the cube root of x squared plus 1, which is what h is. So there's not just going to be 2 that work. So on a question like this in your homework, it'll probably be like a matching question. And just, if you have multiple choices, just put g into f and see if you get the h function. See if you get what you're supposed to get. But that's what we're doing here. There can be more than one. So this was a pair. And then this was a pair. So either one of those 2 pairs give me this. Right? So if you have multiple choice on this, you don't even have to split them apart, because there's a lot of times, like there literally is an infinite number of ways to do it in this case for this problem. So because of that, a lot of times you will just be given a matching question or a multiple choice. And if you're having multiple choice and you're having a tough time, just do what we've been doing. Plug g into f and see if you get this function back.